So now that we've gotten our moments from the 3 moments equation, we're going to be needing those moments to solve, for the splitted beams that we have here. Let's see how it applies. So now, don't forget this, guys. Don't mind me. Don't be like me, guys. So, I said this negative means it's Hugging. So now, it means that at B, are we having Hugging moments? I'll be having this. I'll be having this. And also here, I'll be having this. I'll be having this. Which means I will have this here at the end of this member, and I'll have this here at the end. Which means I'll have here like this at the end of this member. And all the moments here, since it's B, is going to be 115.2. The sign has done its job. Now it's just the magnitude we need. And here we have 451.2 kilonewton. This 451.2 and this moment we just applied is a moment for this support, and indirectly it will have the same moment. That is, the member end will have the same moment as 115.2. This member end will have the same moment. So that is 1, 2, 3, 4 will have the same moment. 1, 2, 3, 4 have the same moment. That's just it, guys. So now, when solving our beam, now that we know that, okay, let me redraw what we have here for member AB. Let me redraw member AB. This is member AB. A UDL and a moment of 115.2, and this is BY1, this is AY, and 30. You can see, guys, how straightforward it is. And what we did here was that we used the equilibrium equation, which is part of it, which is summation Fy. Now we're going to be using another part of the equilibrium equation, which is summation M. This is A, this is B. So this is just basically a zoom of what is there. So summation M, if it says summation, let's use summation M A is equal to 0. It means that about this point A, the sum of all my moments is 0. But how I like to do mine, which is the same thing as what you might do for yours, is that I say anti-clockwise moment is equal to clockwise moment. I think of this as a ball once again. So this moment would rotate it in a clockwise manner. Once also this UDL will rotate it in a clockwise manner. If this is a ball and the UDL is coming like this, it means that the ball will rotate in this manner. And this BY1 will rotate it in an anti-clockwise manner. It means that it will rotate anti-clockwise. But basically in exams, what I just do is I still use the same anti-clockwise, clockwise, but I don't think of it in terms of anti-clockwise, clockwise. I just use my imagination. I just say, okay, if this is a ball, how can I, okay, equals to 0. Ball, okay, BY rotates it in that particular direction times 10, and BY is rotating it in this direction. BY is the only one in that direction, and for the UDL, rotates it in the clockwise direction times 10 times 30 times 10 times 5 plus 115.2. Notice that this is already a moment. No need to times it with anything again. It's already in kilonewton meters. So eventually, when you do this, you'll be having calculator, okay, 161.52 kilonewtons. Now, let's bring out this guy out. Let me use a notch. Let's bring out this guy out. Let's bring that. And before we do that, let's find our AY. For this, we're saying the first one. Remember, AY plus B11 is equal to 300, which means that AY is equal to 300 minus BY1, which is 161.52, which means that AY is equal to 138.48 kilonewtons. So now let's go and enlarge and zoom into BC. So now this is what I have in BC. UDL BC, then BY2, CY1, BY2, CY1 30, and my moments are 115.2 and 451.2. And 451.2. So, applying my equilibrium equations to this, summation Fy is equal to 0. So I'm having By2 plus Cy1 is equals to 300 once again, and summation MB. This time I'm taking moment about B. I'll be having 115.2 moving in the anti-clockwise direction, another one moving in the anti-clockwise direction with respect to B now is CY. Okay. Now the remaining are clockwise, 451.2 plus 30 times 10 times 5. Then I'll be having 115.2 plus 10 CY1 is equal to 1951.2. Then I'll be having CY1 is equal to 183.6 kilonewton. But BY2 plus CY1 is equal to 300, which means that BY2 is equal to 300 minus 183.6, which means that BY2 is equal to 116.4 kilonewtons. So now lastly, I have member CD. Let's look at CD. I'm sure it's still the same 10, of course, yeah. 10. What is just different is the moments at the end, and this should be CY2. You know what we calculated before was CY1, and this should be DY. And here was 451.2. And nothing here. Remember, this is the 451.2 that was here. This is it here. And nothing was here. We didn't calculate a moment for C. You know that your moment for D is 0 already, which I explained. Moment for D and moment for A, 0. So guys, let's continue. What you'll be having here is summation Fy. So we're treating everything here. It's just basically splitting a statically indeterminate beam to statically determinate. So CY2 plus dy to the 100. And summation MC 451.2 plus 10 dy is equals to 30 times 10 times 5. So basically, moment at C, this is C, about C, this is a ball, this will rotate it anti-clockwise, dy is also going to rotate it anti-clockwise, so they are all in one side. They will rotate it in the same direction, but 30 comes and rotates it in an opposite direction. That is why it is in another side. So dy is equals to 104.88. Then I can now say that cy2 is equal to 300 minus dy, which is 104.88. Then I can now say that cy2 is equal to 300 minus that, we'll be having 195.12 kilometers. But remember, I said that RB is equal to BY1 plus BY2. And similarly, RC is equal to CY1 plus CY2. So RB, BY1 plus BY2, which is equals to 116.4 plus 161.52, which is equals to 277.92 kilometers. RC is equals to CY1 plus CY2. RC is equals to 195.12 plus 183.6. RC is equals to 378.72 kilonewtons. So guys, we'll be moving to the other part in the next video, where we'll be calculating the internal stress resultants, which are the shear force and bending moments. Let's get into it, guys.